Okay, so we got the knob working here, the potentiometer, and all it's really doing is just turning that brightness up and down, right? So kind of useful. We're gonna look at some other things we can do. So we're also gonna change the entire strip now. So that'll be really easy with a for loop, right? So it reads the potentiometer from analog 6, stores it into this value called pot, or this variable called pot. But instead of just setting that one pixel, we're going to set all the pixels now. So for int a equals 0, a is less than LED underscore count, semicolon, a plus plus. Parentheses, curly, enter. So I'm just going to copy and paste this. Control X, Control V. Okay. Whoops. There we go. Okay. So we want each one of these to turn green, right? So instead of doing number 2, which is a third one, I'm going to do A because A is going to go across the whole thing. So it's going to read the potentiometer, store the value into a pot, and it's going to set all the pixels, the green value, to potentiometer divided by 4, right? Because 1023 to 255 is a division of 4. Then it's going to show it, and we're just going to wait 50 milliseconds. So let's get that uploading. I should have probably hit upload first and then started explaining it. That's okay. This little stuff shouldn't take long. Cool. There we go. So now, there we go. Okay. So this is pretty useful, right? Having this here, like, like I can actually use this for lighting now. So I can choose how bright this strip is, have another setup, how bright that strip is. I could also hook up another potentiometer and change like this section with this potentiometer, another section with this potentiometer. I could also hook up a microphone to this, and now this will pulse because we're reading analog signals. I could have it pulse to like bass music or something, or have a light sensor on the Arduino, and so as light outside goes out, light inside turns on, right? And so it doesn't have to be a potentiometer. This is just a basic, easy to control example of analog voltage coming into the Arduino. Okay, so I could do that with this, right? I could also choose which pixel is on. Okay, so right now it's setting them all to be whatever color the pot is, right? In the code, I'm going to delete this here. Okay, so right now I have 11. I have 11 NeoPixels that I can use, and the pot is 1024, right? Or 1023, I guess. So what I'm going to do is int pix equals. Let's see, what would we do here? We do LED count. I guess 1023 divided by LED count. So what we're going to do here, what this does is takes the value here. Let's see if I'm doing this right. Yeah, I think I'm doing this backwards. Yeah, 1020. Yeah, I'm doing it backwards. So it should be LED. So LED count divided by 1023. Okay. Times pot. So what it does is takes LED count and divides it into 1023 chunks, right? And then whatever the pot reads, it's going to return. So let's pull out a calculator here to verify this. So let's say it's halfway. So LED count, which is 11, divided by 1023 equals this way, like random number 0.0107 times 512 equals pixel 5. So that's right there. Well, 5.5. 11 divided by 2 is 5.5. So that should work, right? Let's say if I have it about a quarter of the way, so 256 or so. So 11 divided by 1023, right? That's the first thing it does here, equals again the 0.0107, and then times 512, or sorry, not 512, times 256, so about a quarter of the way up, equals pixel 2. Now, it's got all this other stuff back here. This variable, an integer, will not store anything past a decimal. It won't store decimals. It only stores the whole number. So it's going to take this, throw it away, and just store a 2 here. Okay? So yeah, this should work. All right. And then it's going to do a strip.show. My biggest problem with this one is it's just going to keep turning them on. There's nothing to turn them back off. So what I'm going to do here is for int a equals 0, a is less than LED count, a plus plus. Okay, so this will just, in memory, I'm not going to actually do a show after this. Strip.set pixel color a comma 0 comma 0 comma 0. And that's just going to turn them off in memory. It's not actually going to show it. So it turns them all off, comes back around, loops back around, reads the potentiometer. I'll hit upload now. Reads the potentiometer. Okay. Picks a light based on the math I just showed you to turn on. I guess, no, we didn't even turn one on. Whoops. So I missed one of these. So copy this, paste this. So what we're going to do here is pick a pixel, which is going to be pix. That pixel is going to be on, and that'll be, I don't know, we'll make this one blue. There we go. Okay, so for reals this time. Reads the potentiometer, chooses a pixel based on where the potentiometer is, sets a pixel color, or sets one of those pixels to blue, shows it, turns them all off in memory, and then waits 50 milliseconds. So now as I turn the knob, nothing happens. Let's figure out why that is. So we did the math here, and that should be about right. We might need to do some point zeros in here to make sure the floats actually work out. Make sure it adds a decimal within the math. There we go. Nope. Oh, there it goes. Cool. Yep. So we needed to put 0.00 to tell it to use the floating point math. Okay. So now, as I move this potentiometer, it's moving the LED that's on, right? But it goes a little far off. That's all right. We can fix that later. So yeah, we can inspect the math. But it hits that last pixel, hits the first pixel. So yeah, that works pretty well. Cool. Okay. So this doesn't have to be like a potentiometer again. This can be like a gauge. Like the faster you're going, the higher it is. I don't know, close to the distance, I guess. We could have a distance sensor on here. So as I get closer and further away, it shows this on the graph. I could have an accelerometer. And so as I'm accelerating this chip or as I'm turning the chip, I could have this in a circle here. Right? And as I turn this chip, or as I turn the accelerometer or the compass, I could do an ATAN too. We'll be doing that later. That'll probably be the NeoPixel 300 series. I'll show you some trig functions for this. But we're going to be messing with the chip and be able to, keep the top LED turned on as we're moving it around. But yeah, there we go with the knob. So there's one more thing we're going to do with this before we get too far. So we did brightness, we did individual pixels. So now let's try one more thing. We're going to do time. Okay. So this time I'm going to create a global variable called pix. Int pix. Okay, and it's just going to do pic plus plus here. Let's get rid of this here. Okay. Pix plus plus semicolon, and then pix percent equals LED count. This is going to make sure that as soon as it hits 11, it goes right back to 0. Or as soon as it hits LED count, it turns back to 0. Okay? And then we're going to turn it green or blue. There we go. But instead of using the delay here, we're going to do pot. Okay. So now, depending on what it's reading between 0 and 1023, we can go faster and slower with this. And so that's 3 different common ways to use the pot. We're going to do a lot more with it as it comes up, but yeah. So now it's moving it by itself, right? Not touching the pot. If I turn it down, decrease the delay, it's going a lot faster, right? If I increase it all the way, it's going to take 1 second to move. And as I keep bringing it down, there we go, little bits. I'll just bring it all the way down. Now you can barely tell, like, that there's actually a change. Now it's going super fast. There we go. That's a little more reasonable. But yeah, you can control animations with this. So if I were to hook up like 3 of these knobs, I could have one controlling the speed of it, one controlling the brightness, and then in the next video, we're actually going to be controlling color with this instead. So we're going to be writing a big long subroutine. That's going to be our like beautiful master subroutine to control. So that's it for pots right now. Thanks for watching, guys.